Students, so this is regarding the chemical bond, one of the best trick which is very much useful to find out the sigma bonds as well as lone pair of electrons, because it's a vast topic which is going to be covered all the aspects of inorganic part of chemistry, and this is a way to find out the sigma and pi lone pair of electrons to predict the shape of the molecule also based on VSEPR and what a VSEPR theory as well as hybridization. So basically we are doing with this number of sigma bonds and lone pairs. After that we will go for what is the shape of the molecule. This is the first trick which we are going to do. It's the very easiest way to find out the whatever is called here the number of sigma bonds and lone pairs as per VSEPR. ABN, LM, N stands for number of sigma bonds, M stands for whatever is called here number of lone pairs. A is the central atom, B is the bonded atom, N is the lone pairs. Let's do it, Baba. First of all, we will take the example of this one. What's that example we are going to take means PCl6 minus 1. That's going to be valence electrons of phosphorus is 5 and it is going to be 6 chlorine atoms. It's going to be here 7 valence electrons in each chlorine. The minus is going to be included in the total valence electrons because extra negative charge is there. It's divided with 8. Then you are going to get its whatever is called here 6 sevens are 42, 47, 48. 48 by 8 it's going to have 6. So that it's having whatever is called here, there is no remainder, hence the n is equals to, m is equals to 0 and n of PCl6 minus 1 is going to be 6 sigma bonds and m is going to be 0. That's why the formula can be written as AB6L0. So this is one Baba here, one which we are going to do. And next one we are doing with the same example, Gracia, that's going to be PCl4 plus 9. So N or Q you can write, there is no wrong. And coming to the 5 is the valence electrons plus 4 into whatever is called here 7, and this is going to be positive charge subtracted here, then it's going to be divided with 8. So whatever is called here 28, 5, 33, minus 1, 32. That's going to be 32 by 8. How much you are getting, Baba? It's going to be how much? 4. So that it's going to have bonded atoms are going to be 4. Number of sigma bonds is going to be how much? 4. M is going to be 0 because we don't have any remainder. That's it, children. See this. What's the possible general formula of this one? AB4L0. AB4L0. This is the way to find out the simplest whatever is called here the number of sigma bonds and also lone pair of electrons. Got it? And the next one, the beautiful example which we are doing, it's a bit tougher also. That's going to be predict the shape that we will do later in tricky concept. I3 minus 1. I3 minus 1. See Baba here. Coming to the number of sigma bonds, let's do this. It's 3. How many nitrogen atoms are there? 3. 3 into 5 plus 1. Then by 8 you are getting for nitrogen, that's as how much? It's 16 by 8. 2. It's going to be 2 sigma bonds are present here, or it's going to be 2 bond pairs you can say. There is no wrong in that. Nothing is there. No remainder is present. Therefore, n is equals to 0. Got it, children? See this. This is the way to do the problems with respect to this. 2 sigma bonds. Let's go to this. And coming to this, very shortest way to do this is going to be I3 minus 1. N is equals to, what's the iodine? 17th group element. 3 into 7 plus 1. Add one more electron. As such, it is having this negative charge 21. 22 by 8. There is a problem here. So what's that? Let's thrash out the question here. It's going to be 8 2s are 16. How much is going to be the remainder, Baba, here? 4 plus 2 is the remainder. So M is equals to, the remainder is going to be, how many are there? Once again, see here, 8 2s are 16. 4 plus 2, 6 is the remainder by 2. That is going to give us 3 lone pair of electrons. 3 lone pair of electrons. Here I am giving you simplest hint for you all. N3 minus 1, I3 minus 1. 2 sigma bonds. Here also 2 sigma bonds. Seems to be linear. Both of them are going to be linear. But one is going to have 3 lone pairs. The other one is going to have 0 lone pairs here. Got it, children? So this is the way to solve the questionnaire regarding this. And I have given whatever is called, 2 of them I have solved. Based on this concept, you can solve VRF3, VRF5 and xenon trioxide, xenon tetroxide, ICl2 minus 1, ICl2 plus, SF4 and ClF3 also. The questionnaire, you have to solve them all. Okay, children, this is the way of finding number of sigma bonds and lone pairs. It's the very easiest way, and you can solve any kind of question. Thank you, children. Thank you very much for this session, simplest trick.